Differentiation 2, increasing, decreasing functions. So in this video, we're going to look at how to find where is the function increasing and decreasing. So we already saw that if we have a function and we want to look at where is the graph increasing and decreasing, we always read the graph from left to right. So if I'm reading from left to right here, I can see that if I pick any point on the graph, I can see that as I move towards the right, the y value is getting lower and lower and lower until I get to this point here. And then the y value begins to get higher and higher and higher until I get to this point, and then it gets lower and lower and lower again. But if I was to draw a tangent at each of those points, we can see something interesting happening, where we can see that the slope is negative, negative, negative. And at the bottom here, we say the slope is 0. Then we have slope is now positive with respect to the x-axis. Slope of the tangent is positive. Slope of the tangent is positive, positive. And again here at the top, we have the slope is 0. And again, slope to the tangent is now negative again, negative, and negative. So we can actually use this information in differentiation to determine where is the function increasing and decreasing. So in other words, what we say is when the function is increasing, our slope is positive. And of course, in differentiation, the slope is found by getting the first derivative. And if it's positive, that means that the derivative has to be greater than 0. So for an increasing function, slope is positive, so we get where is dy dx greater than 0. If we look at the graph there and we see where is it decreasing, well, it's decreasing when the slope is negative. And again, that means that if we find the first derivative has to be less than 0. So to find the values where the function is increasing or decreasing, we're going to have to find the first derivative, and then we're going to have to solve the inequality. So in other words, our steps are find the first derivative and then solve for where is the first derivative greater than 0 or less than 0, depending on whether you're showing increasing or decreasing, or if it's a cubic like this graph here, we might be looking for increasing and decreasing. In other words, we'd have to solve both inequalities. So let's have a look at an example. So we have find the range of values for x where the function y equals x cubed minus 3x squared minus 9x plus 9 is increasing and decreasing. So it is a cubic function, and it is a positive cubic function, which means it's going to be an n followed by a u shape. So like the previous graph, it's going to be the reverse. So it'll be n followed by u. And we want to know where is it increasing and decreasing. So we don't have a graph, so we can't read off our answers, and in which case we must rely on differentiation. So we take our function, and we differentiate. So we're finding dy dx, so the derivative of x cubed, so I bring down the 3, take 1 away from the power, minus 3x squared, bring down the 2, so I have to multiply it by the 3, which gives me 6, take 1 away from the power, and then minus 9x differentiated is minus 9, and if I differentiate a constant, I always get 0. So my first derivative is 3x squared minus 6x minus 9. I now must find where is this function greater than 0 if it's increasing and less than 0 if it is decreasing. So I basically want to solve first of all. So we're going to let dy dx equal to 0, and then we'll apply the inequality. So now that this is equal to 0, I can divide across by 3. And I solve my quadratic. So the factors that multiply to give me minus 3 and add to give me minus 2 must be minus 3x plus x If I group the first two and take out the highest common factor, and group the second two and take out the highest common factor, that leaves me with x minus 3, and take out 1 as being common, leaving me with x minus 3. Again, these two brackets are the same, so again, take out the highest common factor, x minus 3, which leaves me with x plus 1 equals 0. So if I solve this quadratic, I let my two factors equal to 0, so that gives me x equals 3. And if I let x plus 1 equals 0, I get x equals minus 1. So this is not my answer, this is just where the graph is going to cut the x-axis. I now need to find where is it increasing and where is it decreasing. So let's look at increasing first. So for increasing, we know that dy dx, the slope has to be positive. So in other words, dy dx must be greater than 0. If I sketch the derivative graph here I can see is a U-shaped quadratic because it's a positive x squared. And we've just found that the roots of this are 3 and minus 1. I'm looking for where is the graph increasing, so that means that the derivative graph has to be above the x-axis. So dy dx greater than 0 means the graph is lying above the x-axis. So that means all of this part of the graph is above the x-axis, all of this part of the graph is above the x-axis. Therefore, the values of x that make the graph above the x-axis is beyond 3 and beyond minus 1. In other words, it is increasing when x is less than minus 1 and when x is greater than 3. If I look at where is the graph decreasing then? Well, for decreasing, it must have a negative slope. So in other words, the derivative is less than 0. And if I again look at my graph of the derivative, well, the derivative graph is that same quadratic cutting at minus 1 and at 3. But this time I'm looking for where is my derivative graph less than 0, which means where is the graph below the x-axis. In other words, negative. And it's below the x-axis all here, which means the values that are making the graph below the x-axis is when x is between minus 1 and between 3. So the range of which this graph is decreasing for is between minus 1, less than x, less than 3. So we can also be asked to show a function is increasing or decreasing. So in this case here, we have to show that the function y equals 2x plus 1 over 3x plus 6 is increasing for all values of x as an element of or less minus 2. So just reading the fine print here, what this part here means is that it is undefined when x equals minus 2. In other words, if I have minus 2 times 2 plus 1, and on the bottom I have 3 times minus 2 plus 6, well, what I end up with is minus 4 plus 1, which is minus 3, but on the denominator we end up with 0, and that is undefined. So that's all this little bit up here is saying. That's the fine print. So we can't have x equals minus 2 as an answer. So how do we show something is increasing? Well, if I want to show it's increasing, we have to remember that for increasing, dy dx is greater than 0. So in other words, I need to prove that the derivative is always positive. And the way we do that is we look for a real number squared or a positive constant. So that means we're going to have to take this function and differentiate. So if I look at that function, well, we have 2x plus 1 over 3x plus 6. And if I put that in brackets, we should hopefully spot that that's a function in x over a function x, which means it has to be the quotient rule. And if we go to page 25 in the maths tables, we find that our quotient rule is dy dx is equal to v times du dx minus u times dv dx all over v squared. So if I take u there and I let it equal to 2x plus 1, well, du dx is 2. And if I let v equal 3x plus 6, then dv dx is equal to 3. So all I need to do now is sub that into my formula. So we have dy dx is equal to v, which is 3x plus 6, times u, which is 2x plus 1. Sorry, by du dx I should say there, which is 2, minus u, which is 2x plus 1, times dv dx, which is 3. And that's all over v squared. So if I multiply out the top line there, we have 6x plus 12, and then it's minus 2x times 3, so that's minus 6x, and minus 1 times 3, which is minus 3, and that's all over 3x plus 6 squared. So on the top, we can see then that we're left with 6x minus 6x, which is 0, and 12 minus 3, which is 9, over 3x plus 6 squared. So we have to look at this and go, well, is that positive or is it negative? And we can clearly see it has to be positive, well, because 9 is a positive number. And if I look at the denominator, well, we have 3x plus 6 squared, which is a real number squared. And any real number squared is positive. And if I have a positive number divided by a positive number, then that means that that whole thing is going to be positive. So in other words, 9 over 3x plus 6 squared is definitely positive. So therefore, what that means is that dy dx, the first derivative, is always going to be positive no matter what value of x I sub in there. Because if I even get a negative number on the bottom and it's squared, well, a negative number squared is still going to be positive. So therefore we say that dy dx is greater than 0, and therefore we say, hence, the function y equals 2x plus 1 over 3x plus 6 is increasing for all values of x, except for when x is minus 2. And remembering that symbol there just means for all. So if we go to page 361, and then we have a look at question 7. Question 8. And question 11. I'm going to throw in question 12 as well.